Hello and welcome to another MyMaths walkthrough. This is 5793 angles 4. Okay, so we're going to use angle facts to figure out sizes of angles. There's quite a few angle facts we're going to learn over the course of the next bunch of lessons. These are the ones I'm going to use today are three fairly basic ones, and then quite a bit of a complex one, but it's not too difficult to understand. Okay. So this first one we've got, this is a 90-degree angle over here, so we've got 90 degrees in the corner. So if we know this is 65, to get to this one all we've got to do is do 90, take away the 65, and you can use your calculator or you can just use your brain and just say to yourself, oh, it's 25 degrees in that top corner. So the angle fact there was, if I do a little picture at the bottom here, I've got this thing here, that bit is a symbol for 90 degrees and just means a right angle. Okay. The next one you're probably going to recognize is going to be angles on a straight line, and angles on a straight line always add up to 180, so this whole thing is 180, so all I've got to do is take 61 off 180 and I get 119 degrees in that top corner. So the angle facts down the bottom in our little map here is the angles on a straight line here always add up to 180. Now, one of the things as well that you should mention, it's not just angles on a straight line, but it's angles at a point on a line. So it's angles, let's write that down, angles at a point on a line add to 180 degrees. Okay, so that's the rule for angles at a point on a line. Now in this one, this is angles around a point, some points here, and the angles around a point always add up to 360. Going around a full circle, people seem to know that angles around a circle are 360. My phone's about to start beeping loads. So what I'm going to do is 223 from 360. I'll use a calculator, just be careful. 360 take away 223 is 137, so I've got 137 degrees is the answer. And the rule at the bottom, we'll just do a little picture, so I can do this picture, I'll put some more lines on if I want, and it goes all the way around here. You can put another line up here if you want. It's angles around a point add to 360. Okay, it would be useful if you had these written down yourself, maybe put them in your book or something, so you can always refer back to them if you forget them. Now this one's a little bit more complicated, so these are three basic ones. This one's a little bit more complicated. Now I can in fact use these two rules to figure out the angles here. So for example, if I just ignore this 83 and I look at that thing there, that's a straight line, and angles at a point on a line, they've got 180, haven't they? So if I take 97 off 180, let's start the calculator so we can see it. 180, oops, that wasn't 180, that was 418. What am I doing? 180 take away, what was it, 97, you get 83. Okay, so this angle in here is actually 83 degrees. And then I could do the same thing. I can either say, oh, well look, angles at a point on a straight line at 180, so I could do 180 take away 83. So let's have a look at that one. 180 take away 83 equals 97 degrees. I can get 97 in this spot. Okay, or I could say angles around a point at 360, so I could just say, well, these three at the moment I've got 83 plus 83 plus 97, so if I've got 263. So if I go all the way around the point, I need 360. So if I do 360 take away 263, then I get 97 degrees as the missing angle there. Okay, so it's angles around a point at 360. Or I could have used a slightly more complex rule and said these are called vertically opposite angles. So when you have this crossing with two straight lines, these two here are called vertically opposite angles. These two here are called vertically opposite angles. And the reason they're called vertically is because this is over a vertex. That's called a vertex there. So it's angles opposite each other across the vertex. Vertically opposite angles are called, are actually equal to each other. So as soon as I saw 83 there, I knew that one was 83. So let's just write that rule down. I'll write it on this page. So I'm running out of space, aren't I? Didn't plan that out well. So if I've got any sort of crossing thing, so any two lines which cross, it doesn't matter where the lines are, then these two angles are going to be equal to each other. And these two angles here, that one and that one, they're also going to be equal to each other because they're crossing over this vertex. And the rule is vertically opposite angles are equal. Okay. Often on these types of questions you do often have to write down what the angle is and then get the bonus point for writing down the reason, and you have to write the reason pretty precisely to get the marks for that one. Okay. Right, going up the top here, so I had some sort of pull situation, so somebody was shooting the ball at the corner pocket. I had an angle of 46 degrees, but I actually want to know what this angle was. Well, this is just a right angle on a pool table, and therefore this angle is 90 take away 46, which I think is around about 44 degrees. So I'm going to put 44 degrees in there, and I could just use the calculator to check that, but I believe it's correct. This one, angles on a straight line at a point. Remember, it's at a point. Have to add to 180, so that's going to give me this angle over here as 68 degrees, and again just use your calculator if you're not sure. This one's fairly straightforward. Its angles around the point, so the point is here, angles around this point, add up to 180. Well, if I've got 180, it's, add up to 360. So if I've got 180 on the top, I've got 180 on the bottom to make up 360. So that one was quite nice when I got that one. And then the last one was the ironing board picture. This is a picture of a fan. The ironing board picture. I've got this picture down here, over here, haven't I? So I'm just going to go with vertically opposite angles are equal. There's the vertex. So vertically opposite, so that one and this one must be the same. So down here I've got 80 degrees. And over the vertex again, this one and this one must be 100 degrees because vertically opposite angles are equal. Okay. Now we're going to build up a whole army of rules, so it might be useful if in a book you write these 4 down as a starting point. So you've got the square represent 90 degrees, we've got angles at a point on a line add to 180, angles around a point add to 360, and vertically opposite angles are equal over the vertex. And the more rules you know, the easier things become. If you get stuck with just 1 or 2 rules, you will find things difficult in the future. That's it. Have fun. And I'll just turn this off now.